Hello, my name is Kyle Ludlove, and I will be talking about the article that I read called The Electromagnetic Moment of Static Charge Current Distribution. And the author of this article is Gerald Franklin. In this article, there are 6 main sections. The first section is called Electromagnetic Momentum. The second section is called Electromagnetic Momentum of Static Charge Current Distribution. The third main section is Electromagnetic Momentum of a Magnetic Dipole in a Static Electric Field. The fourth main section is called Electromagnetic Momentum of an Electric Dipole in a Uniform Magnetic Field. The fifth main section is called Center of Energy Theorem. And the sixth and last section of this article is called Hidden Momentum. And I will be going through and explaining what I've learned about each of these and trying to explain how I perceived these sections. So in the first section of electromagnetic momentum, I have these red equations here, which I pulled out to be the main equations that I read through. The first equation there is the Lorentz force, which they used it because they needed an electric magnetic field. This equation shows electromagnetic field exerts force on matter via Lorentz force, which is the equation number 1 up there at the top. The Lorentz force is also equivalent to the second one, which is right below the first one, which this equation is just a simplified form of equation 1 if there's no other force acting on the matter. Then it talks about the conservation of momentum with no external force, which is part of, it goes over or related to Newton's, one of Newton's laws, which, as you can see, it has a partial of the momentum of matter with respect to partial of time, plus the partial of momentum of the electromagnetic with the over the partial of time, and those two are you add them together equal to 0, which represents the third equation I have up there. And this just shows the conservation of momentum, like I just said. The fourth equation I have up there, which is that bottom red one, it just shows the rate of change of the electromagnetic momentum. So that is, just the rate of change, the momentum. The Lorentz force is it describes motion of matter caused by the electromagnetic field, which then will lead into also applying an external force, which gives us these two equations at the top here, 5 and 6, are equations that have to deal with external force that is applied, and it is just added to the equations 1 and 2. So equation 5 is just equation 2 with an external force applied, and equation 6 is equation 3 with an external force applied. And then as you can see, number 7 there is just a combined equation of 5 and 6. Okay. All of these equations follow Newton's three laws of motion. The external force will increase the electromagnetic moments while keeping matter at rest. This contradicts the center of energy theorem, which I will explain later whenever I get to it. This center of energy just says that if the center of energy of a closed system is at rest, then the total momentum is zero, which that leads into hidden momentum, as I explained earlier, which is the last main section of this article. So down 8, these blue equations right here are part of the second main section, which is electromagnetic momentum of static charge, current distribution. This top equation, equation 8, equation 8 is just equation 4 from earlier, but it is integrated over time. So the rate of change of the electromagnetic momentum with only rho 1, which is the charge distribution, with no initial electromagnetic momentum, then this introduces time-dependent current distribution, which is J2, which is the charge density. This increases from 0 to 0 to the final value where it remains the same. There is no external force on on the matter because the charge distribution produces no magnetic field. The time-dependent current produces time-dependent vector, which is represented by equation 9 there, which equation 9 just said electric field and time-dependent vector potential produced by time-dependent and current distribution. In this article, this led into equation 10, which just had the momentum of the charge distribution. That's what the equation 10 is. And equation 10 is just equation 9 placed into equation 8. The electric field, the electric field, which is 9, is just placed into where it is in 8. This only holds true if there's no external force acting upon the matter. So if there's no external force, this led into equation 12 of this article, which is just Coulomb's law applied to the momentum of the electromagnetic in terms of the charge distribution and charge density. Okay. Oh, sorry, I did not show these two equations here. 12 is this one at the bottom. Okay, and then this will lead us into equation 13 by applying Maxwell equation to get equation 12, and then 13. Oh yeah, so this, by applying Maxwell equations to equation 12, we would get equation 13. This is the total electromagnetic momentum of all charge distribution within the volume. Okay, so this will lead to the third section, which I have in black over here.